Trying to get my sound. Okay.
Okay, you can check your sound and I will introduce you in the first, okay? Nice. Okay, Dr. Jill. We can't hear you.
Try this. Is this better?
Yes, it's better, yeah.
Yes. Thank you for your consideration and your patience.
No problem.
I'm ready.
No.
I'm ready
Yes.
to share my screen. Yeah.
Yeah, but in the first, I will introduce you for our colleague. Yes.
Yes.
Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, everyone, and welcome Dr. Gerald Stark. Firstly, I would like to introduce Dr. Gerald Stark. Gerald Stark, PhD, Master of Science, Engineering Management, Certified Prosthetist and Orthotist License, and the Fellow of the American Academy of Orthotists and Prosthetists, Director of Clinical Operation and Technical Support based in he has written and presented numerous topics in prosthetics and orthotics nationally and internationally. In his 32 years career, he has held various administrative positions in engineering, clinical care, product development, and education, as well as mechanical engineering degree and Masters of Engineering Management. He holds a PhD in Organizational Learning and Leadership from the University of Tennessee of Chattanooga. He has served as an instructor for Northwestern University, Georgia Technology, and the University of Tennessee, as well as contributor for a number of prosthetics and orthotics programs. In his career, Dr. Stark has served on the board of director of ISCBO, International Society for Prosthetics and Orthotics, National Commission on Orthotics and Prosthetics Education, NCOPE, and the Academy, where he has been the chair of the Research and Education Council, and is currently the Academy treasurer. He has been honored as one of the few to win both the Train Hard and Hammond Tree Award, as well as Canadian Association Prosthetics and Orthotics Award, as well as being outstanding engineering alumni, outstanding doctoral student, and outstanding clinical educator, and flow the distinction for his numerous academic literature and contributions. Welcome, Dr. Gerald Stark, or as I usually say, Jerry. Yes?
That's fine. Thank you.
Yeah.
I'm so very honored for the invitation to speak to this Egyptian group, and really happy to talk to you about transfemoral fitting. Are there any questions that we have before I begin? Yeah. And Iman, will you be doing the translation?
No, you can start, yes.
Okay. So I'll share my screen, everyone. Is that okay? Yeah. All right. Okay, can everyone see my screen?
Yeah.
Okay, I will go to make it a little bigger. All right, thank you. So I guess one of the things that, Iman, you had mentioned is that you kind of liked a comparison of ischial containment molding techniques. This really was from my LinkedIn post most recently. And one of the things that I was making the comment is that many people try to achieve the same things in different ways. But the thing is that we do this based on our own finger strength. We do this based on our own ability to create the shape. So everyone can hear me okay? Is it okay? Hopefully there's not too much background noise. Yeah. Um, so really what I learned when I was at Northwestern University from Mark Edwards and Tim Statz, I derived this lecture from that comparison. And really there are families of thought. Some of you have probably attended a Moss course or maybe attended the psychotology course, but use different methods, but based on what you find gets you the best outcome and based on patient presentation and the versatility. I've used a variety of methodologies because the patient may be shorter, they may be longer, they may have soft tissue that needs more molding, etc. So actually, ischial containment is quite old. I'm not sure how many of us on the call today were born before 1941 or after, but 1941 is one of the first ones that I see documented, and it utilized a soft interface. And you can definitely see the attributes of the narrow medial lateral socket design, but this one used a soft urethane that was coated in plastic. In 1945, you can also see this need for the parametric shape between the adductor longus, the ischial containment, and the greater trochanter. So this triangular design was actually derived from some of the earlier German methods that were borrowed. And Mr. Haddon and Thomas went to Germany after the Second World War to retrieve this methodology. But there's a lot of ambiguity and difference between these. And this is one of the sockets, 1953. You can see the attributes both of the quadrilateral and the ischial containment, right? They actually have a common ancestor. And this is the common ancestor right here. In this time, there was a relief for the gluteus maximus. There was an ischial seat made of usually of felt or something like that. Then you see the adductor longus. And again, you see this triangular design, but then one direction went to Ivan Long went to squeeze this, and the other direction was the quadrilateral that was a more rounded shape. Yeah. So 1957, some of you recognize the UCBL shape. This is for quadrilateral. This was really nice because the patient could be fit with inside the socket as it was being made. So this was really a great improvement. So Jim Fort and Chuck Radcliffe created this. But the nicest thing about this wasn't really the brims. It was there is a set parameter and a way of learning. Many of us, this is the first socket that we learned to make. And in the 50s, later in the 50s, this borrowed from the Canty style, and this was more like what we would see with narrow ML. So now this is one of the first narrow ML socket designs. Some of you may recognize the name Ivan Long, but he noticed patients with soft adductors need a greater amount of support. And we'll see that this is probably the most important indication for ischial containment. Ischial containment was intended indeed for geriatric amputees with soft adductors. People with strong adductors, younger adults, could tolerate more adduction. They could probably had muscular balance to provide it. In fact, we see now, we'll talk a little bit later, but some of those patients are so strong that when you apply the handhold, they push you off of your ischium. I don't know if you've noticed this. Now, Ivan Long was a strong proponent of a very strong adductor angle. You look here on this picture on the side, look how strong that adductor angle is. And this picture is from 1978. So when you think about how strong an angle they had, this really prevented this abduction. So when you loaded the soft tissue, this prevented the abduction. Now, I worked with Chuck Radcliffe, and he told me one of the reasons that Ivan Long did this is because he couldn't make a quad socket correctly. So there's always that opposite view. Oh, and if there are any questions as I go, please feel free to stop me. And Aman, please let me know if I need to address it. Yeah. Thank you.
Okay. Okay.
1985 is what we maybe think of as the modern system. When you look at the ischial containment of Ivan Long, he was using laminated sockets. In Guth and Savlich in 1985, they actually talked about using thermoplastics. So this, I think, is the maybe the more modern sense of it because of ischial containment utilized the more aggressive placement, and then you could be more aggressive with the geometry because of the plastic use. If you look at some of the people here at this group, there are really some notable people that were future directors of program. And here's Tim Statz from UCLA. Tim Statz, David Liddig, and Chris Hoyt, who is a big proponent of osseointegration. You see how all these alignment practices still are present. This is in the 1980s. This was the UCLA CAT cam above knee socket. You saw Mr. Statz in the previous picture. He wanted to teach this to students and make a more teachable method similar to what Chuck Radcliffe had done. But there was a tendency to keep using brims. And one of the brims, this is actually an old picture of a Dale Barry using an E-post brim. There was the Breaky brim. Some of you maybe remember the Autobach brim that someone had to sit on, and then it would position the socket. This was the mid to late 80s. The issue was that, well, one, could you afford these brims? And two, could you implement them and just have them ready and available? You'd have to have a quite large office. So many people are still casting with their hands. In 1987, let's see, 1987, I was still in college. They had a meeting at ISPO, and they looked at all the different types of shapes from UCLA, Champ, Natural Alignment from Ivan Long, and CAT-CAM from Northwestern. And they noticed there was something interesting. And this is amazing when prosthetists agree. These prosthetists actually agreed on the shape. There were certain things that were common to all socket designs. So in 1990, Mark Edwards and Jack Eulendahl, what they were my mentors, they taught me the system, and they developed the Northwestern system. And it was actually a simplification of some of the other ones, but one that was very teachable to the students. In the 1990s, Tim Statz and Marlo Ortiz developed the SOL technique. And what this did is the posterior area, that's where the ischium and ramus would be. And here's a very heavily perspiring Tim Statz talking to Marlo Ortiz in Mexico, describing this. Now, Marlo was you could see is a much shorter person, and Tim Statz is a very large person. So they had different ways of holding the ischium. So Tim Statz, stockatology, he actually talked about this as a formula for good fit, and they would develop this geometry. And they classified the pelvis as an alpha, beta, or gamma based on how it presented itself. Northwestern actually took a different approach. They said, look, there are only two types of pelvis that we need to think about, male or female. And the male foramen is basically like this, with the index finger and the middle finger, and the female one is wider to accommodate the wider Q angle. It's one of the true examples of gender dimorphia that has different shapes based on gender, and that was to accommodate the wider hip angle or Q angle, right? So Marlo Ortiz in 1999 came up with, he excluded the ischium, so this was only ramal containment, and he was able to see with longer limb lengths, you could actually drop the trim lines below the ischium. Now, when you think about this, it was very novel for its time because of the range of motion. However, when you think about quadrilateral, that is also a sub-ischial containment system. So he was borrowing the best of gluteal loading from quad and then containing the ramus. The way he would, and we'll show you this later, the way he would find the ischium is just with his index finger, middle finger, and thumb. And I find this to be a great method for people who have smaller hands, but still need to apply that firm pressure. So CAD interfaces, that's basically when I started as a prosthetist, mimic the soccer shape. However, it didn't really get to that nice intimate fit of the ramus. And so when you think about now requiring 2, 3, even in the United States, 4 check sockets, if I had done 4 check sockets, my boss would have had a word with me like, what are we doing? So the interface goals, no matter what system you choose based on our discussion today, have to do some things. All of them have to do them. They have to provide axial support, so total surface bearing and ischial-ramal support. They need to reestablish the femur at 7 to 12 degrees, which 7 is for men, 12 for women. They need to establish rotational control, so to eliminate rotation at heel strike and latent stance. And then medial brim comfort. And we're going to talk about this. The medial brim comfort is not always based on the height of the medial wall. Sometimes it's the position of the ramus coming through the socket, and you need to pull your socket backward, posterior, more than you need to lower it, because you probably took a great cast. Have you ever noticed, why should I have to lower this? I think I was in the ramus just the appropriate amount. And then the last one is to really establish preflexion and hold that patient in position. So all the shapes are fairly familiar. One is the anterior pressure. And what we do is we divide the socket into quadrants. So the interesting thing is there's always pressure from the rectus to keep the ischium in position. If you're too loose, the limb will begin to abduct, just like they do with soft tissue. Then the posterior lateral wall angle comes behind the trochanter to provide this support. Some people use channels. The issue with channels is they don't necessarily provide any more support and typically cause some sort of abrasion distally long term. Then the posterior wall angle. Now, this is probably the most important thing and the thing that most people try to get away from. That angle posterior from the adductor to the ischium, and then apply about 12 degrees of pressure. This is important, not just at the ischium, but at the subischial level. And that subischial level is about 32, 37 millimeters distal to the ischium. You need to press and preload the ischium. It's sort of like the Scarpa's triangle for the medial wall. And of course, maintaining the Scarpa's triangle, some of the earlier socket designs really allowed a tremendous amount of rotation. So this posterior medial wall angle, I thought it's worth talking a little bit more about. This is that medial wall angle. And typically I find this is the area that most prosthetists maybe lose their bravery. They don't necessarily do this. And if you don't do this, it loads the ischium more. I don't know if some of you have ever gone bicycle riding or sat maybe on a board that was very narrow. You realize how sore your ischium can be. The subischial triangle actually preloads that soft tissue and unloads it, unweights it from the ischium. The deepest point is about 1.5 inches distal. And you can see this is a slightly retroverted subischial triangle bordered by the hamstrings, the ramus, and the adductor magnus. So again, you can see just how much adduction Ivan Long recommended. Am I speaking too quickly, do you think, or should I change my tempo? Is it okay?
Yeah.
Okay. So you can see how much adduction. Now, do we have the ability to measure that mechanical axis line, which is supposed to be 4 degrees from the midpoint of the trochanter and femoral head, and it's supposed to hit the distal end of the femur and then the ankle, and this is what orthopedic surgeons use. I have difficulty with that as a prosthetist because all I have is a goniometer and plumb line. So what I normally do is I'll place my medial wall, my medial brim, which is about 3/4 of an inch, which is about 25 millimeters, 20 millimeters. And it should hit the distal end. So when I fill the mold, I should have it flat on the table, and then I make sure that I reestablish this adduction angle. The downside is the shorter the limb length, the harder that is to do. So sometimes you have to follow one of the main rules of prosthetics. When you're not sure, you split the difference. So you try to make it as much adducted as you can, but not overly adducted for shorter limb lengths. Here's something to mention is that if we don't load that medial wall, if we don't do it, what happens is the limb abducts. So when you see a lateral gap, so a gap at the top of the socket, what's the first thing many people did? And I did too, by the way. You you would put a foam pad in there. You don't want to do that. If I were to put a foam pad proximal lateral here in a wedge, I would freeze the limb in abduction. That's basically ensuring that I'm going to have posterior lateral pressure. So the thing is, rather than padding here, we should probably be padding the medial wall to pre-compress because maybe I didn't push down hard enough. So ischial ramal containment are two things. There's two types of containment in a sense. The containment basically of the ischium, how proximal you go, and this is based on the residual limb length. But there's also the position of the ramus. How much ramal containment you have is based on the width of the pelvis. So because the men have a more narrow angle, you can get about an inch of containment, forward containment of the ischium. Because women have a more wider angle like this of the greater foramen, you can only get about half of an inch, or it's actually 12 millimeters instead of 25 millimeters for men. So what we typically do, many people will lower the medial wall. But really what they did is they just didn't look at where the ramus was exiting. So before you lower the medial wall, maybe look at where this ramus exit is and pull that backward, pull that posterior more, because that's probably what the main issue was. So the ischial grip is something we focus on, and this is something that you are different between your different hands. My hands, I have to be honest with my hands, I have a very wide palm and I have shorter fingers. My family, I didn't grow up on a dairy farm, but my dad did. So he says my hands have evolved to be good for uh, being a dairy, working in a dairy. So the ischial grip is the greatest amount of difference, and we'll examine those. Maybe there's one that would work for you. One of the most important things is to use this pre-compression stocking. So we use a compression stocking on the on the involved side, and then we use a cotton stockinette and pull them in to elongate the tissue. And then we try to get the seam as far as we can. So I have to really lift the seam and pull it into that position. And then it's to actually take a measure 1 inch proximal to the ischium. And the ribbing of that compression garment lets me do this quite well. So there's just two measurements, adductor longus to ischium, and then rectus to the gluteal area loaded, just loaded so that the bottom blade of the measurement device compresses. So not a lot of compression. If you do too much compression, you're just making a good quad socket. And then you circumferentially wrap. You first begin with the circumferential wrap, then a perineal splint up, and then posterior, you're going to pull to the medial side. Anterior, you're going to have a partner lift as high as you can. If you're by yourself, you do this from the side. Yeah. And then you do recurrent wraps like you would for a hip spica, for a hip disarticulation, actually. So you wrap around the trochanters. So you're getting that tight ML and you're pulling that lateral wall in. And you can see the partner make sure that you do this. So I'm going to jump ahead, but the Northwestern molding, the handhold is similar to this. So you would have your index finger. This is the ischium. I would do that. And then I would use my fourth and fifth to press and provide that adductor pressure to preload it. Now, if someone is very strong, they're very young, what I find is I'll press really hard and I'll have to tell them to relax. But if they squeeze their adductors, I get pushed off of the socket, right? Sometimes we joke we don't know what to do with our thumb. So what I do with my thumb is I preload and then I use my thumb to load the gluteus about 1 inch proximal or 25 millimeters proximal to the ischium. So that's the Northwestern handhold. So you can see this here. I apologize for my lack of nice nails. Most prosthetists don't have great nails because we're always in plaster, right? Unless you're scanning. But you can see where my fourth and fifth are. My thumb is loading the gluteus and I'm applying distal pressure. Now, one thing I have to admit, my fingers would end up like this as I try to lift up on the patient. So I would put the ischium and this closer knuckle right here, the PIP joint, right? And so I would get more pressure. The downside is that sometimes my finger drifts inward, so I got to let my finger go more medial. Any questions so far? Hopefully
I
this
think
is what you, yeah. I'm
I
sorry.
think if anyone has a question, he can raise his hand and just we can give
Okay.
him the mic. Just if
Okay.
anyone raise his hand, yeah.
The problem is I can't see while I'm presenting, so please let me
Okay,
know, okay?
okay, yeah. I will actually, if
All right.
anyone raise his hand, I will give him, I will give him permission to use the mic and talk.
Yes. Yes. So this is the Oser technique, which I think is an interesting one if you're using a liner. Now in the US, I don't know if it's different than Egypt, but I actually did a survey and I found in the US, 78% of the time they're using a liner to provide suspension. I was a little bit surprised by that. But what with the liner, you're already applying the tension. So Oser used an anterior approach. So you would find the ischium from the anterior, you'd apply your thumb to the scarpus, and then apply medial pressure with your index finger. Now, if you're using a liner, this is excellent, and they would preload using a elastic strap, making a figure of eight, and then a medial strap, a perineal strap, a 1 inch elastic strap, 25 millimeters through the perineum. Do you see these right here on the screen? Right here. Now, oh, yeah. So one of the things is I use this elasticity in the same way using elastic straps. So this is the Oser technique. So here you see the liner, here you see the perineal strap and the figure of eight, bigger elastic. I think that's a 4 inch elastic strap, right? So that's applying all the pressure you need. And then, so it's a two-step process. You're holding it here, and then you're reversing position and going distal and establishing adduction and pressing that medial pressure, right? It's the same method, same outcome, just a different methodology. So this is the secondary Oser hold like this. So this might be good if you really want to define the anterior better, or if you have a liner. So this is the Oser grip. Mhm. Now you still can use your fourth and fifth digit to apply subischial pressure. Just watch out for that adductor longus. Every system you look at has an inherent challenge that you need to work with, right? It's just like any car, I guess. So the Moss impression technique now, Marlo really emphasized the ramus pressure because he felt the ischium was rotating out of the socket anyway. So his thing was to actually find it, and John Michael, who recently passed away, would call this the sugar tongs technique, which I like, way to extract. So the ischium was below the middle finger. You applied medial pressure with your index finger and block the ischium with your thumb. Does that make sense? Yeah. So if you have smaller fingers, like some of my students were female and they had large patients, you can really find that placement and really find where the ischium is, find where the ramus is, and then where the bottom of the ischium is. Oh, I think it's outlining it there. So this is the Moss design. Marlo in the post was great enough to say, yeah, he said, my fingers are smaller. I'm shorter, but I still get a great impression of the ischium. You can see how he's doing that right there. Very strong fingers. Yeah. So this is the Moss tongs design. Still with the fourth and fifth, he's pushing if he can on that subischial area. Now, Tim Stats used a little bit different anterior approach, or I'm sorry, a posterior grip. He blocked the back of the ischium and then loaded along the ramus. Now, Tim Stats had very big fingers. He was a very tall person. But you can see how Marlo borrowed maybe the first three fingers of Tim Stats to achieve what he wanted to because he learned from Tim Stats. So this is really when you really want to establish that firm ramus, if you think you can do that. Again, the only difference is maybe the fourth and fifth with what I do pushes on the subischial area. So you can see the shape of the Moss design is actually quite similar. Yeah. It still has a strong ischial crease. Now, where's that from? That's from the quadrilateral. He borrowed that strong gluteal loading from the quadrilateral. So this is the Stats handhold. Now, the UCLA anterior approach, this was a variation of the stats version again, and I think you'll see Oser also had this. You place the thumb in the subischial area, and then you round it around the ischium, and then the ischium rides right at the bottom. In the post, Al Ingersoll was good enough to share with me a method from Pierre Chablot from France. So he also does an anterior approach, but then establishes the line of progression and then the gluteal loading with his fingertips. So I think that's very innovative too. Now, the Sablich design, CAT-CAM or SCAT-CAM, controlled anterior trochanteric alignment method, used an even stronger ischial containment. Now, this is great for people who have shorter limb lengths. So you can see this is CAT-CAM, SCAT-CAM. Scott Sablich was one of my students at Northwestern, so I got to learn from one of my students. And you can see just how aggressive some of these modifications are. They're the same, but just a lot more adjustment of the adductor longus, a lot more relief for the rectus, strong loading of the gluteus. He had this OKC channel that tried to index the femur, but also look here, a strong subischial loading. But this was a much more proximal ischial containment. You can see this strong loading into the gluteus as well. This one, the ischium is on the ring finger, and you're using two fingers along the ramus. Yes, thank you, Aman. I don't know if I'm hearing you. I think
Ayman, you need to open the mic. You need to enable the mic.
do I need to use a mic?
It's open now?
Oh, yeah.
Yeah.
Yeah. That means, Jerry, the distance between seat of ischial seat and pubis emphasis for medial wall will be different independent of design.
It'd be different with the what? Yeah.
Which one? Independent which design we will do it.
In the end, it depends on your hands. It depends on where you get the greatest strength and the greatest success. In the end, I would say a good place to start is the Northwestern design. How's that for a good answer? But then, depending on the limb length, maybe if they're shorter limb length, you could do a Sablich. Maybe if they're a bigger person, you could do the Marlo Ortiz version. Yeah. If you have a longer limb length, the Marlo Ortiz version works very well. Is that a good answer?
Thank you. Thank you.
Yeah, you're welcome. I have to tell you that I use them all. How about that? I like to try different things based on my patients. So I probably do have the beginning of the Northwestern though. Here's Kevin Carroll showing us how he uses a very elastic. Do you remember in that early design, they showed the elastic strap making a figure of 8? You remember that? He does the same thing with the plaster. So he wedges this impact splint up into what we call the natal cleft, which you know what I mean. It's the parasagittal line up the main area. And he goes as high as he can medially into, we say, tease him sometimes, into the sacrum. And then he makes a figure of 8. And then what he likes to do is load medially. That's how important the medial pressure is to him. And he puts his head, he said that's why, he says this joke, he said this is why God made him bald, so that he could help more people, because if he had made him have hair, it would get stuck in the plaster. So, you asked me a perfect question. So I give you all these methods. How do you choose the right one? Well, limb length, the amount of containment you think the patient could tolerate, because some patients don't tolerate it, but need to look at the pelvic structure. Again, the greater foramen, on the pelvic floor, males are like this with the ramus, and females are like this. So how are you going to make sure that you do that? And then soft tissue management, really accommodating that adductor, loading the gluteus, loading Scarpa's triangle, but especially that subischial triangle. So I just want to thank Mark Edwards, Tom Karolewski, Jack Ulandahl, Kevin Carroll, Tim Statz, Marlo Ortiz, Scott Sablich, and Chuck Ratcliffe, all of my great, wonderful mentors that I've had the pleasure of having. And that's the presentation. Is there time for questions?
Yeah. Thank you, Jerry. this
Thank
interesting
you.
presentation, and I think we will need repeat the presentation. My question is, what's the best design you prefer in short stump above knee amputee?
I mean, of the methods I choose, because it's very well documented, very well written, is the Northwestern RIC method. And I can provide you some of the manuals that I had from that time. And if you would like to translate it, that would be great. And then, but I have the best luck because that just gives me a baseline to begin from. If I have a shorter limb length, so I'll go from my index finger and maybe my middle finger. So I can adjust it based on what the patient provides. So I'm not dogmatic in what I choose, but I choose probably the Northwestern in all fairness.
Okay.
And I try to be aggressive in establishing that adduction angle. Yeah.
Yes, I know that. Yeah, yeah. But there are different between bilateral amputee above knee and unilateral when
Oh,
you choose
yeah.
the design.
Yeah. Well,
Yeah.
no, I would say no. In fact, I would not do a quadrilateral for a bilateral patient. But to be clear, I think most people don't fit a straight quadrilateral socket, although, and when they're using CAD, I think they do because the check socket fits more readily. And if they're just using a liner, I just don't think they establish that adductor angle anymore. I think now it's just neutral. So when I have a bilateral, though, I'll really try to narrow the ML so that they can walk. Otherwise, if it's too wide, they really uh, they might hit other anatomy on the pelvic floor.
Yeah, nice, nice.
Youssef,
Yeah.
I think Yusuf Ahmed has a question, so he can talk.
okay, yes,
Thank you, Dr. Gerald, for your presentation. I just want to ask you, is it possible to combine features from different socket design to meet unique
definitely.
patient needs?
I'm glad that you asked that because my goal of this lecture is, of course, I would do it based on what you feel works really well with your fingers, what works well with your strength, and what you're trying to achieve with the patient. Definitely. So I think that's what makes prosthetics so great because you can combine it. Now, if you go and call it the USEF methodology and no one else can use it and they have to pay a licensing fee, that's where, yeah, I think that would be a shame. But I think it's good to share with people. But definitely shorter limb length, I'll increase the containment. Someone using a liner, I'll use the Oser method. Um, but the one thing I want to tell you is any method has advantages, but also disadvantages. One of the things about the anterior approach is you can sometimes bind the adductor longus. Sometimes with the Northwestern, the way I hold it, I have my trim line too anterior of the ischium. So I have to bear this in mind as I modify. So any system is as good or as bad as you want it to be.
Uh, Thank you for that, Dr. Gerald. Thank you.
You're welcome.
Okay. Also, Yusuf Ayman has a question, so he can talk.
No.
Thank you.
Everyone.
Okay.
Sorry.
And
Yusuf Ayman.
أيوة أنا سامعك.
Sorry. طيب.
are there any
I'm
other
going to check.
questions?
I think Yusuf Ayman raised his hand, so
Oh, okay.
May I ask another question? Sorry for
Can
that.
you hear
Yes.
me?
yeah, we can hear you, Yusuf Ayman.
Okay. Thank you, Mr. for this presentation. Please recommend some textbooks about this field.
Thank you.
I'm sorry, what was that? You wanted some text box?
Yeah.
Oh, you wanted do you want some write-up. I can provide that. Is this, I'm sorry if I'm misunderstanding, but I do have a methodology written so you can read it if that's what you wanted. Is that what you're asking? No.
About design of prosthetics and principles.
Yeah. What is the question?
Some textbooks.
Let me tell you.
Can I
You,
read it?
Sorry.
He means Dr. Gerald, he wants a recommendation for textbook for different designs.
Oh,
Yeah,
you
yes.
know, this is very difficult because many of the inventors don't necessarily share it. But I guess the best textbook might be the Atlas, the latest prosthetic Atlas. But I've actually written an article comparing the different designs, so I would be happy to share that with you. But unfortunately, there's not a lot of sharing sometimes between the inventors of these various designs. So that was the intent of this lecture. Um, yeah, I think the Atlas is a good place to start. But I'm happy to send this to you all for you to help people. And I'm happy to send this lecture, actually. Yeah, just let me know. The only thing I ask is if you make it better, or if you have a better Egyptian method, that you share it with me. That's all I ask.
you will visit our canteen early.
I have not visited, so yeah, that would be wonderful if I could help show this to you in person.
Next,
What?
next year, Jerry. Next year.
Okay.
In scientific.
What methods do you use in Egypt? Just so for my own information, what do you like to use?
February
Quad?
or March.
Actually, we use mainly lots of people here utilize as me either maybe choose quadrilateral design, maybe with triangle shape.
Yeah,
This most commonly we use it here.
my teacher Gunther Gale at Northwestern would say, a good fit. Listen, Jerry, a good fitting quadrilateral socket is much better than a poorly fit ischial containment. So, and I think that's somewhat true. If you're fitting the quad very well, a good fitting quad is better than a poorly fitting ischial containment. The most important thing, though, is the reason that your ischial containment probably is not fitting well is you didn't apply enough pressure in the subischial area. Mm-hmm. Yeah, but I think with the subischial, with the narrow ML subischial, or I'm sorry, ischial containment, ramal containment, you can get greater adduction of the foot. And now when I go to shows, I see the foot outset so far. And, that's why Marlo Ortiz got so much attention because he had these young ladies were wearing these sockets and they had such a narrow base of support. So when you have someone that can really walk with a narrow base of support with a transfemoral, you should go for it. Not have them walk like old people.
I can ask last question.
Yes. Looks like Mohammed has a question too.
Jerry, what you prefer? Traditional way for take a cast or scanner by CAD-CAM, something like that?
I'm an engineer, so I have no allegiance. Whatever gets me the best shape. So I've used CAD-CAM.
Yeah.
One thing I have done with CAD-CAM is I have altered some of the models. I think for a quad socket, it works wonderfully. What I have done is actually taken the ischial containment model and had them carve it, and then I'll cut away the medial wall and put a splint and then hold it. So I do a hybrid. So it's really whatever you feel gives you the best. Sometimes if I have enough time, I still use plaster. So I guess I would be traditional in that way. I can tell you that's really because of efficiency. With a plaster modification and mold, I can do it within one check socket. and as opposed to four or five I've seen my colleagues use. And it still doesn't fit that great. I think, unfortunately, in the US, the students aren't able to read a check socket very well. They just put it on a stool, on a table, and they say, oh, it works pretty good. But they never had them walk in it. And I usually have a dynamic check socket, so I'll glue it to the whatever component I have, like a 4-bar knee, and I see how well it works in dynamic movement.
Yes.
And that way I'm still a graybeard. Yeah.
We are still traditional way, sometimes by scan, but traditional way is famous here.
I think the scanning works for probably 80% of the people, probably. And my issue is that sometimes I'm called in when there's a problem, so that might be why I'd probably just take an impression. But I think 75% of the time scanning works pretty good, gets you close, and then you can dial in. But I think what really helps is if you could do this by hand, you can correct your CAD model even better. Mm-hmm.
Exactly. Yeah. Yes.
I have a question related to the influence of these designs on the gate parameters. Does they have influence on the changing of the type of gate, changing gate kinematics, stride length, all of these, the different designs?
That is such a great question. And because it's rather ambiguous whether or not it does. Patients tell us they like it better. They like the narrow base of support, but we just haven't measured what is it that they're feeling. So I think if you're a researcher, if you're looking for a project, that would be wonderful to just compare a quad versus ischial containment in a gait lab and see what does that narrower base of support. Now, I would instruct the researchers, it makes no difference if you don't try to get them as adducted as possible. That should be your goal, to get the adduction as narrow as possible and the base of support as narrow as possible. There has been some research done, but they didn't do that with the alignment because the researchers weren't familiar with prosthetic alignment. And I would read the paper and I'm like, if they had just thought of that. But I think that would be a wonderful modern paper, just comparing quadrilateral with the same patient and make ischial containment. All prosthetic research, though, is difficult. It's rather ambiguous, isn't it? Because we have each individual patient and they all walk kind of their own way. But I think that would be great. That would be a great project. Indeed.
Thank you.
Thank you. Hey, everyone. Thank you so much for your time. And thank you for your patience as I do this lecture in an airport in New York. I'm at LaGuardia Airport. So I'm sorry for all the music in the background and everything. So thank you for your patience.
Thank you, Jerry. And
thank you.
I hope see you again. Thank you.
Thank you. Thank you. Bye-bye.
Thank you, everyone. Bye-bye. Thank you. All right. Bye-bye.
Bye-bye.